Hello and welcome back to the Cloudcraft podcast. I am George Palangattil, and today we are going deep into a topic that sits right at the center of modern hybrid cloud architecture: AWS Direct Connect SiteLink. When we talk about cloud, we are often talk about agility, global reach, automation, and scalability. But in the real world, most enterprises are not purely cloud native. They are hybrid. They still have data centers, manufacturing plants, branch offices, research labs, logistic hubs, and highly regulated environments that cannot move everything to the cloud overnight. In many organizations, the applications is in AWS, but the data source might still be in a factory. The analytics platform might be in the cloud, but the operational system might be in a regional data center. The development teams may be global, but the workloads, uses, and compliance boundaries are spread across multiple physical locations. This is where networking becomes extremely important. Traditionally, if you wanted to connect multiple enterprise sites together, let's say Prague, Frankfurt, London, Singapore, and Mumbai, you probably used MPLS, carrier Ethernet, lease lines, or some from private LAN. These networks are reliable, but they are often expensive, slow to provision, and not always flexible when the business needs to scale quickly. On the other hand, using the public internet gives flexibility, but the performance can be unpredictable. You may see variable latency, packet loss, routing changes, and limited control over the path of your traffic takes. AWS Direct Connect already gave enterprises a private way to connect on-premise environments to AWS, bypassing the public internet for more consistent performance. AWS describes Direct Connect as a dedicated private connection from your network to AWS that can provide consistent, low latency performance. But AWS Direct Connect SiteLink takes this one step further. SiteLink allows customers to send traffic between Direct Connect location over the AWS global network without the traffic needing to enter an AWS region. AWS introduced SiteLink as a Direct Connect feature that enables data center from one Direct Connect location to another, bypassing AWS regions and using the shortest path across the AWS global network. So instead of thinking of Direct Connect only as a private on-ramp into AWS, we can now think of it as something broader, a way to consume the AWS global backbone as a private pay-as-you-go enterprise backbone. This is why I like to describe SiteLink as backbone as a service. Today we will cover 5 areas. First, what SiteLink actually is and how the architecture works. Second, how to implement it using Direct Connect connection, private or transit virtual interface, and Direct Connect gateway. Third, the BGP routing mechanics, including ASNs as path behavior, route preference, and common design pitfalls. Fourth, security, segmentation, encryption, and resiliency. And finally, the business strategy and real-world use case where SiteLink makes sense. So, let's get started. At a simple level, AWS Direct Connect SiteLink is a feature of AWS Direct Connect that lets you connect your on-premise location to each other using the AWS global network. Before SiteLink, if two data centers were connected to AWS Direct Connect location and you wanted those two data centers to communicate through AWS, the traffic typically had to enter an AWS region. A common design was to use Direct Connect, a transit gateway, and someday transit gateway peering or region routing construct. That architecture worked, but it had 3 important disadvantages. First, the traffic path was not always optimal because the packet had to go into a region and then come back out. Second, it introduces a regional dependency. If your objective was only site-to-site communication, the region keeping part of the data path. Third, it could add additional cost, especially when transit gateway data processing was involved. SiteLink changed that model. When SiteLink, traffic between direct connect location takes to the shortest path across the AWS backbone and does not enter an AWS region. AWS explained that direct connect locations are interconnected using AWS global infrastructure, and SiteLink traffic between locations use the shortest path on the AWS backbone without traversing AWS regions. The core components are straightforward. You need a direct connect connection. This can be a dedicated connection or a hosted connection through an AWS Direct Connect partner. AWS states that if you already use Direct Connect through a direct or hosted connection, you already have what you need to use SiteLink, and no physical connection is required. You need a virtual interface, commonly called a VIF. SiteLink can be enabled on a private VIF or a transit VIF that is attached to a Direct Connect gateway. The Direct Connect gateway acts as a global logical hub. AWS describes the Direct Connect gateway as a global and highly available resource used with SiteLink enabled VIF. Once multiple SiteLink enabled VIFs are attached to the same Direct Connect gateway, those sites can exchange routes and send traffic to each other over the AWS global network. The important point is this: you do not need to deploy resources in AWS region just to use SiteLink. That is very powerful design principle because the AWS region is no longer in the data path for site-to-site traffic. Let me give a practical example. Imagine a company with three major sites: a manufacturing plant in Germany, a data center in Ireland, and an analytics facility in India. Each site connects to an AWS Direct Connect location. Each Direct Connect connection has a private or transit VIF. Those swifts are attached to the same DXGW and SiteLink is enabled. Now, the German plant can send telemetry to Ireland. Ireland can replicate data to India. India can send process result back to Germany. The traffic moves over the backbone between direct connect locations without going through a VPC or transit gateway inside an AWS region. That is the architecture shift. You are not just connecting to AWS anymore. You are using AWS to connect your global estate. Let's talk a bit about the implementation model. The good news is that SiteLink is not a completely separate service that requires new circuits, new appliance, or a new overlay. It is a feature you enable on a supported Direct Connect virtual interface. AWS states that SiteLink can be turned on or off using the AWS Management Console, CLI, or API on an existing or new private or new virtual interface attached to a Direct Connect gateway. A key point is that SiteLink is any-to-any between enabled VIFs on the same Direct Connect gateway. If five sites have SiteLink enabled and are attached to the same Direct Connect gateway, you effectively create a global private mesh between those sites. But you also have control. If one site should access AWS VPC resources but should not participate in the site-to-site mesh, you simply do not enable SiteLink on that VIF. This makes the design flexible. Now, we should also be clear about what SiteLink is not. SiteLink is not a replacement for VPC networking. It is not a replacement for transit gateway when you need to connect hundreds of thousands of VPCs. It is not a full SD-WAN control plane. And it does not remove the need for good routing design. Think of SiteLink as a private backbone transport option between direct connect location. You still need to design segmentation, routing policy, resilience, encryption, monitoring, and operational ownership. That brings us the most important technical topic, BGP. Now, let's go one level deeper. When you create a direct connect virtual interface, your customer ought to establish an external BGP session or eBGP session with an AWS Direct Connect logical device. AWS explains that when a WIF is created, the customer ought to establish an eBGP neighbor relationship with an AWS Direct Connect logical device, often referred to as an ALD. And these logical devices are part of the Direct Connect gateway control and data plane. The ALD learns prefix from your on-premise router and advertise those prefix into the Direct Connect gateway control plane. The Direct Connect gateway then advertise those prefix to other SiteLink enabled waves attached to the same Direct Connect gateway. This means SiteLink is not a static tunnel, it's a dynamic routing environment. Let's take a simple example. Site A advertise header A and Site B advertise header B. Both WIFs are SiteLink enabled and attached to the same Direct Connect gateway. AWS learns header A from Site A and advertises it to Site B, and AWS learns header B from Site B and advertises to Site A. The result is site-to-site reachability over the AWS backbone. But here comes one of the most common design issues, ASN planning. In BGP, the AS path is used to prevent routing loss. If a router sees its own ASN in the AS path, it normally rejects the route. So, if all your sites use the same autonomous system number, your routers may reject the routes that AWS advertises back to them. This is a classic SiteLink gotcha. There are two common solutions. The first option is to use unique ASNs per physical site. This is often the cleanest design. The second option is to configure BGP features on your customer managed routers, such as allow ASN or vendor-specific local AS behavior. This allows the router to accept prefix even when its own ASN appears in the AS path. The exact configuration depends on the platform which you use, like Cisco, Juniper, Arista, or any other platform. Now let's talk about path preference. AWS Direct Connect supports BGP attributes that allow traffic engineering, including AS path prepending and ABGP communities. AWS documentation explains that Direct Connect routing can use BGP community tags and AS path attributes to influence preferred routing paths. This matters when you have two or more paths. AWS also supports local preference BGP community tags for private and transit waves, such as low, medium, and high preference communities. So, as an architect, you need to vary intention. Do you want to active or do you want active passive? Do you want regional preference? Do you want one side to act as a backup path for another? Do you want symmetric traffic or is asymmetric traffic acceptable? These questions must be answered before production deployment. Now, let's talk about security. A common misconception is that private connectivity automatically means secure connectivity. Private connectivity reduces exposure to the public internet, but you still need proper segmentation, encryption, and governance. There are three areas to design carefully: segmentation, encryption, and route control. First, segmentation. One simple way to create hard separation is to use multiple direct connect gateways. For example, you may have one direct connect gateway for production, another for non production, and another for a regulated environment. Each direct connect gateway becomes a logical trust boundary. On the customer side, you can map those to different VRFs or routing domains. On the AWS side, you can associate them with the appropriate VPCs or transit gateways. This helps you avoid accidental route leakage between environments. Second, encryption. AWS Direct Connect does not mean your traffic is going over the public internet, but some industries still require explicit encryption in transit. For high bandwidth direct connect use case, MACsec is often the right option. MACsec or Media Access Control Security provides layer 2 point-to-point encryption over the cross connect between your router and the AWS Direct Connect devices. MACsec provides data confidentiality, data integrity, and data origin authenticity at layer 2. And AWS also encrypts data at the physical layer as it flows across the AWS network. MACsec is a hardware-based near-line rate encryption option for 10 Gbps and 100 Gbps direct connect links, used for high throughput or regulated workloads. This is important because IPsec can introduce overhead and throughput limits depending on hardware and packet size. MACsec can be better suited when you need high bandwidth and low overhead. However, remember this: MACsec is point-to-point on the Ethernet link. It protects the link between your device and the AWS Direct Connect device. It is not the same as end-to-end application encryption. For highly sensitive workloads, you may still use TLS, application level encryption, or IPsec overlays depending on the requirement. The next one, route control. Security is not only encryption. Security is also deciding which network is allowed to talk to which network. With SiteLink, if you enable multiple VIPs on the same direct connect gateway, you can create wide connectivity very quickly. That is powerful. But it also means bad route hygiene can create unintended reachability. A good SiteLink deployment should look boring in production. Route should be predictable. Failover should be tested. Prefix should be expected. There should be no surprises. Let's move into resiliency and operation. SiteLink can only be as resilient as the underlying direct connect design. If you have one direct connection in one facility with one customer router, then SiteLink may work, but is not highly resilient. For production workloads, you should design with redundant connection, device direct connect location, device customers' devices, and preferably device carriers. AWS provides the Direct Connect Resiliency Toolkit, which helps customers select resiliency model. Order the appropriate number of dedicated connection, avoid terminating redundant connection on the same AWS devices, and test failover by bringing down BGP sessions. This is extremely useful because many network designs look resilient on paper, but fail during real events due to a hidden shared dependency. Now let's look at the business side. AWS Direct Connect pricing includes several components such as capacity, port aways, and data transfer out. AWS states that Direct Connect has no setup charges or minimum fee, although partner, carrier, and local provider costs may apply separately. For SiteLink specifically, the feature is off by default and can be turned on or off at any time. When enabled, data travels over the shortest path between direct connect locations. This creates a very different commercial model from traditional telecom. With MPLS or leased private WANs, you often commit to fixed capacity, fixed location, and fixed contract term. With SideLink, you can use AWS global network more elastically, especially when your connectivity requirement changes over time. But there is still a practical challenge. AWS provides the backbone and Direct Connect services. But you still need to connect your physical site to the Direct Connect location. This is where partners can add value. This partner model is useful when customers do not want to manage carrier selection, local circuits, procurement delays, and operational support across many countries. Let's look on some real-world use cases. Global data center interconnect. This is one of the common use cases. If an enterprise has multiple data centers already connected to AWS Direct Connect, SiteLink can provide an alternative or backup path between them. AWS Architect Guidance describes SiteLink as a way to route traffic between Direct Connect location through the AWS Global Network backbone without traversing an AWS region. One another common use case is MPLS augmentation or backup. Many enterprises already have MPLS. They may not want to replace it immediately, but they may want to additional path for resilience or cost optimization. AWS discuss MPLS and Direct Connect integration as a way to improve private cloud connectivity while addressing reliability, performance, scalability, and security challenges. So, let's summarize. AWS Direct Connect SiteLink changed how we think about Direct Connect. It is no longer only a private connection into AWS, it can also be used as a private global backbone between enterprise sites. Technically, the design is based on Direct Connect connection, private Tor transit view, Direct Connect gateway, SiteLink enablement, and BGP route exchange. Architecturally, the biggest value is that site-to-site traffic can move over the AWS global backbone without entering an AWS region. That can reduce latency, simplify the data path, and avoid some of the regional dependency seen in older design. But SiteLink is not magic. You still need to design BGP carefully. You need to plan ASNs, route filtering, path preference, segmentation, resiliency, encryption, and monitoring. For security, consider separate direct connect gateways for isolation, MACsec for layer 2 encryption, where supported, and strong route control to prevent accidental network exposure. For operation, use the Direct Connect Resiliency Toolkit, test failover, monitor BGP, and maintain a clear runbook. And from a business point of view, SiteLink represents a shift from buying fixed global telecom capacity to consuming a global private backbone, more flexibility through AWS and its partner ecosystem. If you are modernizing a hybrid network, connecting global sites, reducing MPLS dependency, or supporting high bandwidth workloads such as media, analytics, AI, or disaster recovery, AWS Direct Connect SiteLink is absolutely worth evaluating. That's all for today's deep dive. I am George Palangattil. Thank you for listening. And as always, keep building, keep learning, and keep architecting for resilience. Thank you.